matrix times A equals 0, and the identity matrix times A equals A. So any 2 by 2 matrix A. So it says any. So that means we can't just use some 2 by 2 matrix. We can't actually put down numbers, because we have to be able to have this true for any 2 by 2 matrix. So if we came up with some matrix like 3, 1, 7, 47, well, maybe it happens to be true for that matrix. So we have to figure out a way to be able to show that it's true for every matrix. So we need to write about this in a general form. So we do the same thing we have everything set up in, where we use variables. Because if we have it as A, B, C, D, then, well, any 2 by 2 matrix, we can just swap out A, B, C, D for actual numerical values, and we'll have any 2 by 2 matrix. This will be true for any 2 by 2 matrix. So we've got that as an idea. So now we can just try multiplying. If this is going to work for this, this A here, A, B, C, D, that's a stand-in for any 2 by 2 matrix at all. So if we can show that the 0 matrix times this comes out to be 0 anyway, then it's got to be true for all of them, because they're just going to wind up swapping out the variables A, B, C, D for actual numbers. So let's try this. 0 matrix times A equals 0. Well, if we got the 0 matrix, then we're going to have 0, 0, 0, 0, because it's multiplying against a 2 by 2. So our A is A, B, C, D. This is actually pretty easy matrix multiplication, thankfully. 0 and 0 times A and C. Well, hey, look, that's going to crush it down to 0. We know we're going to have to get a 2 by 2 matrix, because we started with 2 by 2 times 2 by 2. 0, 0 on BD. Well, 0 times B, 0 times D. Hey, that comes out to be 0. 0, 0 on AC. 0 times A, 0 times C. Hey, that comes out to be 0. 0, 0 on BD. 0 times B, 0 times D. No surprise there, it comes out to be 0. So we see, because it's got nothing but zeros that we're multiplying by, whatever it's going to hit is going to get turned to a 0. So that's why the 0 matrix multiplied by any matrix at all winds up coming out to be the 0 matrix. So this checks out. And we can see that if we had, put it as the 0 matrix multiplying from the right as opposed to the left, basically the same thing's going to happen, because whatever we're multiplying against, it's going to hit nothing by 0, so it's just going to get turned to zeros automatically. So 0 matrix multiplied against any matrix becomes the 0 matrix. Next, the identity matrix times A. Let's show that that becomes A. So identity matrix, well, A is a 2 by 2, so that means our identity matrix will have to also be a 2 by 2. So 1's on the main diagonals, 0's everywhere else. Main diagonal, 1, 0, 0, 1. Main diagonal has 1's, and then everything else will have 0s. So in this case, not many zeros. A, B, C, D. So this will take a little bit more thought. 1, 0. So 1, 0. On AC. So 1 times A, we're going to have to get a 2 by 2 because it started with two 2 by 2 matrices. 1 times A comes out to be A. 0 times C becomes 0, so we've got A. 1 0 on BD, well, 1 times B comes out to be B. 0 times D comes out to be 0, so we get just B. 0, 1 on AC, 0 times A comes out to be 0. 1 times C comes out to be C. Hey. 0, 1 on BD, 0 times B comes out to be 0, 1 times D comes out to be D. Hey, that checks out, wound up being the same thing. So it's a little bit harder to see why the identity matrix is working, but basically what it's doing is when you multiply some other matrix by it, since it's got just a 1 in one place, it's seeing, hey, who is at the same location over here? A is at the same location. B is at the same location. So they wind up popping out. For this one down here, 0 and 1, it's saying who's at the same location? C, D wind up, so they get to pop out as well. Similar thing winds up happening if we multiply the identity matrix from the right instead of from the left. Try it out for yourself. Take a look if you're curious about seeing it. All right, so that shows everything that we've got. We've got a pretty good understanding of how matrices work at this point. We're ready to go see some of the cool things we can start doing with them. So we'll talk about some new ideas in the next section, the next lesson, and then 2 lessons from now, we'll see just how powerful these things can be for solving really problems that would seem really difficult. We're going to turn so easy so quickly. All right, we'll see you at Educator.com later. Bye.